This video is a quick refresher of our scientific notation. I know you've learned about it in the past, but you may not have used it in a while, so this refresher could be useful. So when numbers are in scientific notation, they used to take up a lot of space on a paper. They either had a whole lot of zeros in the beginning or a whole lot of zeros at the end, and we wanted to shrink that down and not have to count those zeros when we're trying to say the number. So scientific notation takes care of that by pulling out the powers of 10. So we still have numbers that are non-zero numbers, and those all go in a part that I like to call the coefficient. I've heard it called other things in other textbooks. In engineering, they refer to this part as A. And the restrictions on A are that it has to be greater than or equal to 1. So what that means is you will not have a 0 before the decimal point. It has to be at least a 1, and it has to be less than 10. So you can't have 10 right here or something higher. The highest you can ever have right here is a 9 point something. The reason why is because this exponent here is going to multiply the coefficient by 10 and move the decimal point one way or another. And that exponent can either be a positive number or a negative number. So I'm going to talk about positive exponents first because they're kind of the easy one. So if it's a positive exponent, what that means is you are actually multiplying by 10. So you're actually going to multiply by 10. So if we have this example here, 7.2 times 10 to the 9th, then if I were to pull out a calculator and see what this looks like on a calculator, which you won't have to do. If we took 7.2 and we multiply that by 10, the decimal point moved. It used to be in between the 7 and the 2, and now it has moved to the right. If I multiply that times 10 again, then I add a 0 because that decimal point keeps moving over to the right. And if I did that 9 times, the decimal point would move a total of 9 times from where it used to be. So the number would become 7,200,000,000. So every time you multiply it by 10, that decimal point moves a power of 10. Negative exponents are similar, but the difference is a negative exponent is not really multiplying. If you remember back from algebra, a negative exponent really means that that thing is in the denominator. So instead of this saying times 10, it's actually 1 over 10. So we use negative exponents still for positive numbers, but they're just very small. They're greater than 0, so they're positive, but they're less than 1, so they're like decimals or fractions. So if we take that same example, that 7.2, let's pull up the calculator just to make sure we're doing things correctly. So we've got the 7.2, but it's got a negative exponent. So instead of multiplying by 10, we're actually dividing by 10. Notice the way the decimal point moves this time. It moves over to the left. So instead of having 7.2, I have 0.72. If I divide by 10 again, I get 0.072. So we can see that if we actually use the negative exponent. So if we had 7.2, and I'm going to do this a way that I don't want you to do later in life, and we do times 10, and then we put the little caret to put a power, and then we do negative 1. See, it does the same thing. So a negative exponent means we're dividing by 10. So this number here, this 7.2 times 10 to the negative 9, really means divide it by 10 9 times and move that decimal point 9 times to the left. So that answer would become 0.000, there's like 8 zeros, and then 7.2. So there's some practice of putting numbers into scientific notation. In this class in chemistry, you won't ever be asked to take numbers out of scientific notation because that would make them take up space again, and we want to make things take up less space. But sometimes your calculator will give you a number not in scientific notation, and you have to report it that way. So if we look at this, we're going to take out those non-zero digits and make them our coefficient. And the restrictions are that this has to be greater than 1 but less than 10. So that tells me the decimal point has to go in between the 4 and the 5, and then I will keep the 6. So the decimal point is going to have to relocate to here from over here where it was. So that means I'm going to need the decimal point in the 4.6 to move to the left. So this time the exponent is going to be a negative number. So I'm going to count how many times that decimal has to move. 1, 2, 3, 4. So then that would be 4.56 times 10 to the negative 4th. I'm not going to do this example, but I'm going to jump over here and look at this one where not only do we want to put this in scientific notation, we also want to round it to 2 significant figures. So I'm going to start by saying, well, the coefficient would be 2.28, and it would have a negative exponent, and that would be a -2, but that's currently 3 significant figures. If I want to round it to 2 significant figures, that would become 2.3, but this part stays exactly the same. I didn't move the decimal place, I just rounded the digits in the coefficient. So it would be 2.3 times 10 to the -2nd.